Game theory is a fascinating field that studies how people make decisions in situations where the outcome depends not just on their own choices, but also on the choices of others. Imagine a chess match, a business negotiation, or even deciding where to eat with friends. These are all examples of strategic interactions. Game theory provides a framework to analyze these scenarios, helping us predict what rational players might do. In this video, we'll explore the core concepts of game theory from basic definitions to real-world applications, making it easy to understand even if you're new to the topic. The heart of game theory are players and their strategies. Players can be individuals, companies, or even countries, anyone making decisions in a strategic setting. Each player has a set of possible actions known as strategies. The choices they make can affect not only their own outcomes but also those of others. For example, in a business rivalry, each company must decide whether to lower prices, invest in advertising, or innovate. These decisions are interconnected, and understanding this web of choices is what makes game theory so powerful. Every strategy in a game leads to an outcome, and each outcome has a payoff for the players involved. Payoffs can be anything from profits and points to satisfaction or utility. The goal for each player is to choose a strategy that maximizes their own payoff, given what they believe others will do. This creates a dynamic environment where everyone is trying to anticipate and respond to the actions of others. Understanding payoffs is crucial for predicting behavior in strategic situations. Games in game theory can be classified in several ways. Some are cooperative, where players can form alliances and share rewards, while others are non-cooperative, with everyone acting in their own interest. Games can also be zero-sum, where one player's gain is another's loss, or non-zero-sum, where cooperation can benefit all. Understanding the type of game helps us choose the right strategies and anticipate the behavior of others. Another important distinction is between simultaneous and sequential games. In simultaneous games, players make decisions at the same time without knowing what others have chosen. In sequential games, players move in turns and later players can see earlier moves before deciding. Chess is a classic sequential game, while rock, paper, scissors is simultaneous. The timing of decisions can dramatically change the strategies and outcomes. One of the most famous concepts in game theory is the Nash Equilibrium. This is a situation where no player can improve their payoff by changing their strategy as long as others keep theirs unchanged. In other words, everyone is doing the best they can given what others are doing. Nash Equilibrium helps explain why certain outcomes persist, even if they're not the best for everyone involved. Dominant strategy is one that gives a player a better payoff no matter what the others do. If you have a dominant strategy, it's always your best choice. However, not all games have dominant strategies for every player. Recognizing when you have one can simplify decision-making and help you anticipate the moves of others. Prisoner's dilemma is a classic example in game theory. Two suspects are questioned separately and must decide whether to confess or stay silent. If both stay silent, they get light sentences. If one confesses and the other doesn't, the confessor goes free while the other gets a heavy sentence. If both confess, both get moderate sentences. The dilemma shows how rational choices can lead to worse outcomes for everyone. Coordination games are situations where players benefit from making the same choices. For example, deciding which side of the road to drive on or choosing a meeting place. The challenge is to align decisions without direct communication. Success depends on expectations and sometimes on conventions or signals. In the Battle of the Sexes game, two players want to coordinate but have different preferences. For instance, a couple deciding between a football game and a concert. Both want to be together but each prefers a different event. The challenge is to find a compromise that satisfies both, highlighting the importance of negotiation and understanding. Zero-sum games are competitive situations where one player's gain is exactly another's loss. Chess, poker, and many sports are zero-sum games. The total payoff is constant, so players are always in direct opposition. Strategies in zero-sum games often focus on anticipating and countering the opponent's moves. Non-zero-sum games, cooperation can create value for all players. Business partnerships, environmental agreements, and even friendships often fall into this category. Here, players can work together to achieve better outcomes than they could alone. The focus shifts from pure competition to finding mutually beneficial solutions. Any real-world interactions are not one-off events but repeated over time. In repeated games, players can learn from past behavior and build trust or punish betrayal. This dynamic allows for strategies like tit-for-tat, where cooperation can be sustained through reciprocity. Repeated games help explain how long-term relationships and reputations develop. Information plays a crucial role in game theory. Some games are played with perfect information where everyone knows all previous moves, like chess. Others involve imperfect or incomplete information where players must guess or infer what others know or intend. The amount and quality of information can dramatically affect strategies and outcomes. In games with incomplete information, players often use signaling and screening to reveal or uncover information. For example, a job applicant might signal their ability through education while an employer screens candidates with interviews. These techniques help players make better decisions when not all facts are known. Backward induction is a method used to solve sequential games. Players start by thinking about the final moves and work backward to determine the best strategy at each stage. This approach is common in chess and other games where planning ahead is crucial. By anticipating future moves, players can make better decisions in the present. Sometimes, the best approach is not to stick to a single strategy but to randomize among several options. This is called a mixed strategy. For example, in sports, a player might mix up their moves to keep opponents guessing. Mixed strategies add unpredictability and can be optimal in certain games. Evolutionary game theory studies how strategies evolve over time, especially in biology and social systems. Instead of rational players, it looks at populations where successful strategies become more common. This approach helps explain behaviors like cooperation, competition, and even altruism in nature. Game theory has wide applications in economics. It helps explain market competition, auctions, bargaining, and even pricing strategies. Businesses use game theory to anticipate rivals' moves and to design better products and services. Understanding strategic interaction is essential for success in the economic world. Game theory is also used in politics, where parties and candidates make strategic decisions to win elections or pass legislation. From forming coalitions to negotiating treaties, understanding the likely moves of others can be the difference between victory and defeat. Political scientists use game theory to analyze voting, lobbying, and international relations. Negotiation is a classic example of strategic interaction. Each side tries to get the best deal, anticipating the other's moves and possible concessions. Game theory provides tools to analyze negotiation tactics, from making credible threats to finding win-win solutions. Successful negotiators understand both their own goals and those of their counterparts. Auctions are another area where game theory shines. Bidders must decide how much to offer, considering what others might bid. Different auction formats like English or sealed bid auctions require different strategies. Game theory helps participants maximize their chances of winning while avoiding overpaying. Social dilemmas occur when individual interests conflict with the group's best interest. Examples include overfishing, pollution, or public goods. Game theory helps us understand why people sometimes act against the common good and how incentives or rules can encourage cooperation. In many modern settings, the value of a product or service increases as more people use it. This is known as a network effect. Game theory helps companies design strategies to attract users and build networks, from social media platforms to ride-sharing apps. Strategic interaction is key to success in these environments. Behavioral game theory studies how real people make decisions, which often differ from purely rational models. Factors like fairness, trust, and emotions can influence choices. By incorporating psychology, behavioral game theory provides a richer understanding of strategic interaction in the real world. Game trees are diagrams that map out the possible moves in a sequential game. Each branch represents a decision, and the tree shows all possible outcomes. Game trees help players visualize strategies and anticipate the consequences of each choice, making complex games easier to analyze. Credible threat is a warning that a player will take a specific action if certain conditions are met, and the other players believe it will actually happen. In negotiations or conflicts, making credible threats can influence others' choices and lead to better outcomes. Game theory helps identify when threats are believable and effective. Commitment can be a powerful tool in strategic interaction. By committing to a course of action, a player can influence others' decisions. For example, a company might commit to a price cut to deter new competitors. Game theory shows how commitment can change the balance of power in a game. Game theory is everywhere, from sports and business to politics and everyday life. Companies use it to set prices, governments use it in diplomacy, and even animals use it in nature. By understanding the basics of game theory, you can make smarter decisions and better predict the actions of others in any strategic situation. Wrap-up: game theory provides a powerful lens for understanding strategic interaction in all areas of life. By analyzing players, strategies, and payoffs, we can predict outcomes and make better choices. Whether you're negotiating a deal, playing a game, or making everyday decisions, the principles of game theory can help you succeed. Thanks for joining us on this journey through the basics of game theory.